So now that we've talked about comparing two fractions, we've talked about the order of operations with fractions, we could also look at how to average with fractions, or really averaging with mixed numbers, I would say. So if we were given a problem like the one that I have, 3 and 1/4, 3 and 1/12, and 2 and 5/6, and we wanted to find the average of those three numbers. Remember that the way that we find the average is we take the sum of the numbers and we divide by the number of numbers. Well, the same thing is true for fractions. We're going to take the sum of the numbers and we're going to divide by the number of numbers. So the sum of the numbers in this case would be 3 and 1/4 plus 3 and 1/12 plus 2 and 5/6. And then to divide by the number of numbers, well, there's three numbers, so I would say divide by 3. So there's a couple of different ways that we could look at starting, but if we're going to have order of operations, then we might as well use the order of operations. So the order of operations would tell me to look in the parentheses first. And inside the parentheses, I have three numbers, three mixed numbers, and their fractional components. The denominators are 4, 12, and 6. And so if I wanted to find an LCD, well, know that we've done this with three numbers, but I guess maybe we have. So we could do the same sort of process though. We could say 4 is 2 times 2, 6 is 2 times 3, and 12 is 2 times 2 times 3. Believe that's right. And so if we look at it, there are a couple of different ways. So let's just go through and find the LCD the way that we know. Highest occurrence of each of the prime factors. Well, 2 occurs twice right there. And then 3 occurs once. It occurs once here, and it occurs once there. So I can pick either one I want. So that's there. But really what I'm looking at is saying, well, 4 is 2 times 2, which occurs in 12. And 6 is 2 times 3, which also occurs in 12. So my LCD actually just becomes 12. So then if I wanted to add these numbers together, I could find a common denominator like 12, convert everything to that common denominator, and then just add these mixed numbers. Okay, so I'm going to try this without writing down this additional step. If you need to write down an additional step, obviously that's perfectly fine. So for the first one, I have 3 and 1/4, but I want that to actually be 3 and some number of 12ths. So in order to get from 4 to 12, I need to multiply by really the missing factor. So the missing factor between 4 and 12 is 3. So if I multiplied 4 by 3, I would get 12. And if I multiplied 1 by 3, I would get 3. So then 3/12 must be equivalent to 1/4. So now with this second one, 3 and 1/12, well, that fraction is already in an equivalent form with 1/12 as denominator, so I don't need to do anything there. And then this last number is 2 and 5/6. Well, again, I'm trying to get a common denominator of 12 here. And if I'm at 6 and I need to get to 12, I either just need to know that 6 times 2 is 12. Or if I have the prime factorization written down, I can look and say, well, I have a 2 and a 3 here in 6. And to get from 6 to 12, it looks like there's an extra 2. So when I take 2 and multiply by 5, I get 10. It's important to note here that it's not just whatever the missing factor is that goes up top. We're multiplying whatever the numerator was, in this case it was 5, by the missing factor, which was 2, to get to 10. All right, and then I'm still going to divide this sum by 3 whenever I find it. Now, here's the sort of tricky part, if you will. I have to add rather, the bits in parentheses. So the easiest way for me to add mixed numbers is to add their whole number parts, 3 plus 3 plus 2. So that should be 8. and then add their fraction parts. 3 plus 1 plus 10. So that should be 14. And divide by 3. Now, the 8 and 14/12 is not a common method of expressing a fraction because it's improper and it's also a mixed number. But really what we want to do is to convert this to an improper fraction rather than a mixed number because I'm about to have to divide. So how do I convert this from a mixed number to an improper fraction? Well, remember I take the whole number part and multiply it by the denominator, and then whatever I get as a result, I add the numerator to that, and then put it all over whatever my denominator was. So I had 8 as the whole part, this guy here. I'm going to multiply by 12, and then I'm going to take whatever that product is, so 8 times 12, and I'm going to add it to the 14. So 8 times 12 is 96. Let me write that over here. So that's 96 plus 14 over 12. And so then this ends up being 110 over 12 as a mixed number. All right, so 110 over 12. And then I'm dividing by 3. Here again, if I'm dividing by 3, I could actually write this dividing by 3 as dividing by 3 over 1. If I wanted to look at this as a fraction, 3 is really the fraction 3 over 1. So now if I want to actually perform this mathematical operation, remember we said, well, if you want to divide a fraction, you're really multiplying by that fraction flipped over, the reciprocal. So instead of saying that I am multiplying by, or instead of saying I'm dividing by 3, I'm really multiplying by 1/3. And then we've talked at length about multiplying fractions, that when we're multiplying fractions, we're really multiplying straight across. Numerator times numerator and denominator times denominator. So 110 times 1 is 110. And then 12 times 3 is 36. Okay, so then that looks pretty good, except for the fact that I know that both of these numbers are even. So that means that I should be able to pull a 2 out as a prime factor. So if I did that, that would be 55 times 2. And then on the bottom here, that would be 18 times 2. And then I could cancel out that common factor on top and bottom, and I would end up with 55 over 18. And that appears to be simplified or reduced. So the average, as a improper fraction anyway, the average of 3 1/4, 3 1/12, and 2 5/6 is 55 over 18.